Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections of the combination of solids using the Solid Edge software. So in this problem statement, we have a hemisphere of diameter 50 mm, which is resting on its curved surface centrally on top face of the frustum of a rectangle pyramid of base 80 mm cross 60 mm and the top face of 60 mm cross 40 mm, with the height being 55 mm. We need to draw the isometric views of the combination of these two solids. So before we proceed with the construction, let us understand the type of solids given in the problem statement. So first, we do have a hemisphere whose diameter is 50 mm, and this hemisphere is resting centrally on top face of a frustum of a rectangle pyramid. So we have got to construct the frustum of the rectangle pyramid. So the bottom face, which is a rectangle, is measuring 80 cross 60 mm, whereas the top face, being a rectangle, is measuring 60 cross 40 mm. And the height of this frustum of the rectangle pyramid is 55 mm. So, with this data, we need to construct the combination of the solids given. So, first, let us draw the orthographic projection of the combination of these two solids and then proceed towards constructing the isometric projection. So, we'll begin our construction by selecting the line option. So let me select a line of thickness 0.18 and draw the XY line, that is the reference line. So for time being, let me just keep the midpoint off. Let me select the line option again and draw the top view of the combination of these solids using a line of thickness 0.50 mm. So first let me construct the bottom face of the rectangle pyramid, which is having a total length of 80 cross 60 mm. So I'll assume that it is resting on one of its shorter edges. Even the inverse can be done, that is, you can place the rectangle on one of its longer edges because it is not exactly told. So let us just consider it to be a rectangle of 80 cross 60 resting on one of its shorter edges. So let me just move the XY line. So this marks the top view of the bottom face of the rectangle pyramid frustum. So now the top face of the frustum is also a rectangle because it is cut by a plane parallel to the XY line, and this is measuring uh, 60 cross 40 mm. So now let me just draw the rectangle outside, which is measuring 60 cross 40. So 60 is the longer edge, followed by the 40 mm, which is the shorter edge. So for time being, I'll have this rectangle here. So since it is concentric, let me just draw the diagonals of this rectangle so that I get the center point. So let me select a line of 0.13 mm, draw the diagonal. Similarly, draw the diagonal of this smaller rectangle, that is the top face of the frustum. Now let me just select this rectangle and go for the move option. So keeping this center, I'll align the center. So I get this point of intersection. So I'll just keep it here. So now let me just trim the diagonals. So now let me just connect the corners by using the 0.5 mm line. So this marks the top view of the frustum of the rectangle pyramid. Now on this I need to place a hemisphere. So the top view of the hemisphere is nothing but a circle. So let me just go select the midpoint option now. So the midpoint of this two sides I'm getting. So you can just see that I'll place the circle exactly at the midpoint, the intersection of these midpoints. So let me just select the circle option. So the circle marks the top view of the hemisphere, and the hemisphere is having a diameter of say 50 mm. So from this point of intersection, I'll draw a circle of 50 mm diameter. So now let me just go for the split option. I'll select this entire line and split it at this point and this point. So you can just see that it is a split. So again, split option, select this entire line, point of intersection. Similarly, this line, point of intersection, this entire line and point of intersection. So now you can just see that these two are separate entities. So since it is covered by the hemisphere, let me just indicate them by using the dotted line, which represents the hidden surface. So now I need to draw the front view of the combination of the solids. So again, let me select the line option, select a continuous line of thickness 0.13. So let me draw the projections from the bottom face of the rectangle, and next also from the top face of the rectangle. So anyways, the height is going to measure 55 mm. So from the center, so from here let me draw the axis line, so which is having a height of 55 mm. So now let me select a line of thickness 0.50. So I'll just join these end projection lines, the end projectors of the top face and the bottom face, then the complete bottom face of the pyramid and the top face of the pyramid. So now from here I need to draw the semicircle. So let me just revert back to 0.13. So the diameter is 50, so the radii will be equal to 25. Now let me select the circle option and draw a circle of radii 50, diameter 50 from the center. Select the circle option. So from here I'm going to draw a circle of diameter 50 mm. So if I just extend the projection lines, you can just see that it is going to meet exactly at the circumference of the circle like a tangent. So trim option, trim this part. Okay, it is a hemisphere, so I need to just uh, mirror. Yeah. So now let me just trim this circle. Use the extend to next and extend this. So this part is visible. So let me just change the thickness to 0.50. With this, we complete the orthographic projections of the combination of the solids. So let us do the dimensions. So this is 60 cross 80, that is the bottom face of the pyramid. This is 40 cross 60. Next, this is the diameter of 50 mm. So the height of the frustum of the pyramid is 55, and that of the hemisphere is 25. So the total height is 80 mm. So with this, we have completed the construction of the orthographic projection of the combination of the solids, that is the hemisphere resting centrally on the top face of the frustum of a rectangular pyramid. So now we need to replicate the same on the isometric sheet. So now let me select a line option. Let me just keep the midpoint off, and from any arbitrary point, let me start constructing the uh, bottom face of the pyramid. So let me take the first shorter edge, that is 40 mm, 60 mm. So draw the line. So let me take the longer edge, that is 80 mm, at an angle of 30 degrees, followed by the shorter edge of length 60 mm at an angle of 150. Similarly, 80 at an angle of minus 150, and then complete the bottom face of the rectangle pyramid, that is 60 mm at an angle of minus 30. So now in order to draw the axis, let me draw the diagonals. So from the point of intersection, true length of 55 mm, which represents the height of this frustum. So from here, you can just see that towards 80, I'm going to take 60, and towards 60, I'm going to take the shorter edge of 40 of the top face of the rectangle pyramid. So here, I need to draw a line of length uh, 30 mm. Okay, it is 20. So 20 mm at an angle of minus 30, followed by, so this is 80, and towards 80 we have got the longer edge of 60, so 30 here at an angle of 30 mm. So now towards this shorter edge of 60 mm, I've got to construct the shorter edge of 40 mm, so I'll be drawing a line of length 40 mm at an angle of 150. Similarly, 60 at an angle of minus 150, followed by the next edge, that is 40 at an angle of minus 30, and then complete the rectangle. So let me join this corners. So select the end point and join this to the end point. So this is how you get the construction. So now let me draw the diagonals for the top face of the rectangle. And from here, I need to draw the height of the hemisphere, which is equal to, say, 25. And next, I need to draw the circle, which is enclosed in a square, or square of side 25. So it is 12.5 at an angle of minus 30. So 12.5 at an angle of 30, from which I'll be drawing a line of length 25 at an angle of 150. So 25, and the angle is minus 150. Okay, it is the radii that I'm taking, so it is the diameter. Okay, so let me just consider the diameter is 50 mm. So from here, draw a line of length, say 25 at an angle of minus 30. So 25, angle is 30. So the total edge length of the square is 50 at an angle of 150. Similarly, 50 at an angle of minus 150. Similarly, 50 mm at an angle of minus 30, and complete this. So now let me use the 4 center method to complete the circle, for which let me select the midpoint, click OK. So from this corner, midpoint of the opposite edges, Similarly, from this corner, midpoint of the opposite edges. So now let me go for drawing the circle by using the arc by center point. So the first center is this and the radii is this. So let me sweep a circle. Next, from this point to this point, sweep a circle, sorry, an arc. If any of the corner points are open, that error will happen. So let us just zoom in and check. So this is the arc by center point. So let me just select the opposite line. Similarly, this is the point of intersection. This is the radii. Sweep an arc from the point of intersection. This is the radii and sweep an arc. So the circle is over. So since the circle is completely visible, the top surface of the hemisphere, I'm going to change the thickness to say 0.50. So now I need to cut an arc. So I'll go by arc by center method. So I'll select this point and some point which is a tangent, and then just make it a circle, I mean an arc, like it is tangent to both the endpoints. Change the thickness to 0.50. So this completes the construction of the hemisphere. So now I need to darken the sides which is visible. So first let me select this. So all this thickness, change it to 0.50. So here this is a continuous line, and here also it is a continuous line. So what I'll do is I'll go for the split option, select this entire line, and then split it at this point of intersection. So you can just see that it is a separate line now. Similarly, select this entire line and split it at this point of intersection. So you get to see this. So there are different entities now. Change the thickness to 0.50. So this part of the frustum is visible, whereas this is not visible because it is covered by the hemisphere. So now let me just go for the angle between. So this is 30 and this is 30. So everything is done in the iso scale. For example, just see here, this is 80, and exactly for the 80 side I've taken one more longer edge which is 60, and similarly this is 60 and the shorter edge here is 40, and the height of this frustum is 55. And next, coming to the hemisphere. So the hemisphere, let me just go for the distance between. The center distance, it is iso, this is the true scale 25. Okay, and this circle is constructed by enclosing this circle in a square of 50 sides. So this completes the construction. So now I need to scale down this to the iso scale. So select the entire uh, combination of solids and then go for the scale option, and then change the scale to 0.82 times and ensure the copy is off, and then place it at the same point. So this is the iso scaled combination of the solids. You can just verify now. See here, the 80 length is reduced to 0.82 times of 80, which is equal to 65.6, and 40 has reduced to uh, 60 side has been reduced to 49.2. Similarly here, 32.8. Okay, so even the height of the hemisphere, it has been reduced to 20.5 times, and then the height of the frustum, it is 45.1. So all these are the iso dimensions. Even the square for which the circle was constructed, even it is reduced to 41. So this is the isometric construction of the combination of the solids, that is a hemisphere resting centrally on the top of the frustum of a rectangle pyramid, whose base side is 80 cross 60 and the top surface is 40 cross, yeah, 60 cross 40, and the hemisphere is having a diameter of 50 mm. So with this, we complete the drafting of the combination of solids in both the orthographic as well as the isometric views. Thank you all for watching.